Hello guys, good evening. You are welcome to my YouTube channel, the A.Please. So watching this video, endeavor to subscribe, like, share and comment. It is very important. Now please, as you're watching this video, endeavor to subscribe, like, share and comment. So please, and tonight I shall be taking us organic chemistry, a part of organic chemistry. We know that organic chemistry related to organic and inorganic chemistry. Tonight I shall be taking us organic chemistry, and my name is Tutor Joseph. You are welcome to my YouTube channel, the Explicit Tutorials. Now, what is the meaning of organic chemistry? Organic chemistry is a branch of science that deals with the study of the compounds of carbon, except its oxides, carbides, and carbonates. All right. That is what organic chemistry is. It is a study of the various compounds of carbon, except its oxides. Okay, there's carbides and carbonates. That is the meaning of organic compounds. Now, the principal elements that we shall be discussing in organic chemistry is carbon. You know that carbon is called an ubiquitous element because it's found in both plants and animals, and it's found in period 2 and group 4 in the periodic table. Who was the first scientist to arrange elements in the periodic table based on increase in atomic number? It is Henry Moseley, and he was only the first person that stated the modern periodic law. Then Dimitri Mendeleev was the first scientist to arrange elements based on increase in atomic mass, which was very wrong. His theory was corrected by Henry Moseley's theory, which states that elements are arranged in the periodic table based on increase in atomic number and not increase in atomic mass. Therefore, now the carbon, being an ubiquitous element, has certain features, peculiar features that distinguish it from every other element. One, it has the ability to catenate. Catenation is a process whereby an element forms double or branched or linear compounds with itself. Two, it has a valency greater than 2 but a maximum of 4. Please take note of that. Apart from carbon, there are other elements that can catenate. Sulfur can catenate, nitrogen can catenate, even phosphorus can catenate. So please take note of that. On a broad note, organic compound is divided into 2. Organic compound is divided into 2, or organic chemistry, organic compound rather. Now we have one, the aliphatic or open chain. They are open chain actually, and they are called acyclic compounds. Now the aliphatic or acyclic organic compounds, they are organic compounds that do not form rings, all right, which means that carbon atoms are usually branched or straight. If I have this is normal butane. This is normal butane, all right, normal butane. This is normal butane, all right, it is straight. If I decide to add CH3, this branched, it is straight or branched, and it is usually open. That is what we are after. So the second one is a closed or cyclic compounds. Now these closed or cyclic compounds, they have the ability to form rings. They have the ability to form rings, and we have 1, 2, 3. This is cyclopropane, because we have 3 carbon atoms. If I have this 1, 2, 3, 4, this is cyclobutane. If I have this 1, 2, 3, 4, 5, 6, this is cyclohexane. Remember, hexane is 6. If I have this is cyclopentane, 5 carbon atoms. So please take note of that. These closed or cyclic compounds, they are now divided into 2, the homocyclic and heterocyclic. All right, homocyclic and what? Heterocyclic. Now the homocyclic are compounds that attach themselves to a benzene ring, in which you have just carbon and hydrogen. You have carbon and what? Hydrogen present in the benzene ring. But the heterocyclic, the word homo means the same, right? Carbon and hydrogen only. But in hetero, you have carbon, you have hydrogen, you have oxygen, you have sulfur, you have phosphorus, you even have nitrogen, as the case may be, alright? These are called non-benzenoid compounds. Now you now have the aromatic compound. The aromatic compounds are compounds that form benzene ring or benzene ring itself. They have the ability to form what? Benzene ring, and they are called what? Benzenoid compound. So please let me quickly give you something. This is benzene. This is, if I have OH attached to a given benzene ring, it is called what? A phenol. If OH is attached to a benzene ring, it is called what? A phenol. But if CH3 is attached to a benzene ring, it is called what? A toluene. Alright, take note of that. If I have double CH3 attached to a benzene ring, it is called what? A xylene. It's called what? A xylene. Please take note, when two benzene rings are attached together, they are called naphthalene. When two benzene rings are attached together, they are called what? Naphthalene. When three benzene rings are attached together, they are called what? Anthracene. Please take note of that. Now let us now discuss homologous series. I believe what I've said so far is quite understood. Now let us discuss homologous series. Homologous series. Homologous series. I believe it's recording. Yes, it's recording. Now homologous series. Homologous series. Now what are homologous series? Homologous series are organic compounds that are conformed to general molecular formula in the same functional group. They are organic compounds that are conformed to a general molecular formula and the same functional group. Now, what are some features of these organic compounds, of this homologous series? One, the same molecular formula. That's a molecular formula, right? Then two, they have the same functional group. They have the same functional group. Alright, the same functional group. And three, they undergo a similar reaction. And four, they have similar method of what? Preparation. And five, they have variable physical properties. All right, they have variable physical properties. And six, two consecutive members differ with molecular formula CH2, all right, or 14 units. All right, it is called 14 units because carbon has molecular formula atomic mass as what? 12. 12 plus 2 is what? 14. So these are the features of what? Homologous series. These are the features of homologous series. It is very, very important you take note of the features of homologous series. If you are preparing for JAMB, WAEC, NAPTEP, GC, NECO, post-UME, it is very, very important to take note of the features of what? Homologous series. Now let us look at the various homologous series. The various homologous series. Please permit me to erase this for a reason. Now, I have first, I have alkane. Alkane, they have molecular formula as CN H2N plus 1. Then we have the alkenes. The alkenes, they have CN H2N, that's all. Then alkynes. Alkynes, they have CN H2N minus 2. And you have alkanols. Alkanols are also called what? Alcohols. And they have CN H2N plus 1 OH. So this OH is the hydroxyl group, and that is what gives it the physical what? The chemical properties. This is 2. We now have the alkanoic or carboxylic acid. Alright, I have CN H2N plus 1 COO CN H2N plus what? 1. Now I now have the alkanal. The alkanal is otherwise called what? The aldehyde. Alright, so it has molecular formulas CN H2N plus 1 CHO. It is very, very good you understand or you commit this formula to memory. It is very, very important. Okay, so you now have the esters. Now the esters are the otherwise called what? Alkanoids. Alkanoids. Alright, and you have formula to be CN H2N plus 1 COO CN H2N plus 1. Alright, and again you now have the alkanone. The alkanone is otherwise called the ketones. Right, ketones. You have to be CN H2N plus 1 O, then CN H2N plus 1. Alright, you have the ether. Ether. Alright, ether has CN H2N plus 1 CO, then CN H2N plus 1. Alright, which one again? We have the amines. Amines are otherwise called alkyl amines. Acanamide. Okay, acanamide. Yeah, acanamide. Alright, so you have CN H2N plus 1, then CONH2. Alright, you can see now that the amines, they have two functional groups. Alright, the ether functional group and the amines functional group. Alright, so the next one is amines or acanamide. Alright, you have CN H2N plus 1 CO, then CN. Okay, amines, that is NH2. Alright, you now have acid chloride. Acid chloride is CN H2N plus 1 COCl. Alright, you now have acid anhydride. Acid anhydride is CN H2N plus 1, all brackets, in the brackets here, then CO2, bracket closes, then O outside. Now I now have the acyl. The acyl has formulas CN H2N plus what? 1. So please take note of that. Plus 1. Then the acyl halide. Acyl alkyl halide, all right, you have it to be CN H2N plus 1 X. All right, that X there connotes what? The halide. So please, these are the various homologous what series. How many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. At least, please, it is before you, as you are studying organic chemistry, the first step you have to take is to know the formula of a given homologous series. It is very, very important. Now, please, let me please say this. Now, this HCnH2n plus 1 represent what? The arrow group. That is the methyl group. This arrow stands for what? Methyl or methyl. And this methyl is what? CH3. So, if I don't want to write CnH2n plus 1, I can simply do it as arrow OH. Alright, so this OH is this, then everything, this CnH2n plus 1 is what? This arrow. You can do the same for others, okay? So it is acceptable that way. So at this point, we call it a day on this particular aspect. Hope it's recording. Yeah, it's recording, thank God. So at this point, we call it a day on this particular one aspect. The next thing we have to do is to treat alkane separately. Now please, I'm still saying it, sometimes they'll ask us that the alkanes are conformed to a general formula as dash. They'll give us, they brought a question on alkyl halide, they brought on alkanoic acid, they brought on ester, alkanoids, they brought on aldehyde, carboxylic acid. Oh, this is wrong. H. I was wondering. So they brought on this actually. So these are the ones I've seen questions on. Okay. Then this and this. So they don't joke. They don't ask you that the alkanes are conformed to a general formula as. If you don't know, you just looking at the computer bamboozle. You are confused. Please take note of the formula. I repeat, take note of the formula. Commit everything to memory. Now the next step is to treat alkane as a single homologous series. Alkane. Now alkane. Now what do we know about the alkanes? Alright? Alkanes. Now alkanes are otherwise called what? Fins. And they are what? Alright. They are almost inert in form because they do not have what? Functional group. So please, the alkyl group determines the physical properties of an organic compound, while the functional group determines the chemical properties of organic what? Compounds. Just as we have electron to normal elements determining the chemical properties, then the neutron determines the physical property of an what? Element. So how do we prepare what? Alkanes. Alright, preparation of what? Alkanes. Alright. 1. We can prepare alkanes by reacting an alkali with sodium acetate or with sodium ethanol. An alkali is a base. It could be potassium hydroxide or sodium hydroxide. Now I have CH3 COONA. Now this compound is called what? Sodium acetate. Sodium acetate or ethanoids. Sodium acetate or sodium ethanoids. If I should react with an alkali called what? Caustic soda or sodium hydroxide, I will produce a methane plus potassium what? Carbonate. So sodium carbonate. Now methane is produced, and methane is what? An alkane. Alright, so we have successfully produced what? An alkane from what? Sodium acetate or sodium ethanoate. If I should react the same sodium acetate with potassium hydroxide, I will definitely produce methane again and potassium carbonate. the NA will change to what? K, the same thing. Alright, so please take note of something. NB. Soda lime. Soda lime is a mixture of caustic soda and what? Quicklime. Quicklime. It is called caustic soda because it is detrimental to the skin. It causes injuries or it harms the skin. The quicklime, it is the only drying agent for ammonia. Okay, quicklime can dry ammonia and silica gel. Quicklime and silica gel can dry ammonia. So please take note of that. Now, soda lime is a mixture of caustic soda and what? Quicklime. Now, during this process, soda lime is preferred to just caustic soda because one, it is non-deliquescent. Two, it does not attack glass. Alright, so these are the two reasons why soda lime is preferred to caustic soda. It is not deliquescent and it does not attack glass. So please take note of that. It is very important. Now, what is another method of producing? What's that method of producing alkane? Then two, it is produced through the catalytic hydrogenation of unsaturated hydrocarbons. Now, if I don't want to make use of this long name, I can simply write addition reaction. Alright, addition reaction. You know that the unsaturated hydrocarbons are the alkenes and alkynes. Unsaturated hydrocarbon, alkenes and alkynes. Hydrogenation means the addition of what? Hydrogen. So if I have CH2 double bonds, CH2 double bonds plus hydrogen, remember, catalytic hydrogenation, that is, it occurs in the presence of catalysts, hydrogen or nickel or palladium. Alright, so these are the catalysts that are used during addition reaction. During this process, ethane is what? Produced. This is what? An alkane. And this is what? Ethane. Alright, so we have successfully produced. This one is alkene. Alright, you know I told you it is only unsaturated hydrocarbon that undergo addition reaction. Please, alkanes never undergo addition reaction. So please, which means that during addition reaction, the catalysts used are hydrogen, nickel, or what? Palladium. Take note of that. Alright. Okay, this one is alkene. Now alkyne, CH, alkyne, then plus H2. Don't forget the catalyst is very important to write it, nickel or PT. Now looking at what we have here, we are going to produce ethane, but it is not balanced. We have two carbon atoms balanced. Then we have 4 and we have 6. Therefore we add 2. So 2 times 2, 4, 5, 6. Now this is what? An ethane. And this is an alkane. Alright, so this one is an alkyne. So, which means that unsaturated hydrocarbons can undergo addition reaction and not alkanes. Take note of that. So these are some of the methods of producing alkanes. Alright, so let us now discuss the reaction that alkanes undergo. Reactions of alkanes. What kind of reaction do they undergo? Reactions of alkanes. Reaction of alkanes. One, they undergo combustion reaction. This combustion reaction is common to all organic compounds. It is common to all organic compounds. What does it mean? It is a process whereby a molecule born in air to produce carbon dioxide and water only, or it is a type of reaction in which heat and energy is produced during the process. And what formula is used to calculate combustion reaction? I'll write it. CX HY plus X plus Y over 4. Then oxygen, it burns in oxygen, it liberates carbon dioxide and what? Water. Right, so this is the formula to calculating combustion reaction. It is very, very important. Then 2, it can also undergo elimination reaction. Elimination what? Reaction. Now please, the reverse of addition reaction, hope it's recorded. The reverse of addition reaction is what? Elimination reaction. It means the removal of what? Hydrogen atom. That is dehydrogenation. Alright, if I have C2H6, I want to remove 2 molecules of what? Hydrogen. It becomes C2H5. And this is what? An alkane. Alright, and this is an alkene. Alright, so this is elimination reaction, the reverse of what? Addition reaction. Number 3 is what? Substitution reaction. Substitution reaction is a type of reaction in which an atom or element takes the position of another atom or what? Element. A good example is a reaction that occurs between methane and chlorine gas in the presence of a UV light, that is ultraviolet light. Let's do the reaction. This is CH4. I'll react it with what? Chlorine in the presence of what? UV light. During this process, HCl is produced first. Now I've taken one H from here, so I'm left with what? CH3. And I've taken one L from here, I'm left with what? Cl. Now this is what? A monochloromethane. Alright? Monochloromethane. We have produced this. This will come over to this place again. CH3Cl. We'll react it with Cl2 again. Don't forget, UV lights acting as a catalyst. Now HCl will be produced definitely. I've taken one H from here, so I'm left with what? CH2. And I've taken one L, add it to this, I've taken one Cl, add it to this, becomes what? Cl2. This is what? A dichloromethane. And it is used as what? Solvent. It is used as what? Solvent. Bring this idiot again. That is CH2Cl2 plus Cl2. Don't forget, UV light. HCl is definitely produced first. I've taken one H from here, so I'm left with what? Just CH. And I've taken one Cl from here, so add it to this, becomes what? Cl3. And this is what? A trichloromethane. And please, it is also called chloroform. Please take note, another name for trichloromethane is called what? Chloroform. And it is used as an anesthetic during surgical what? Activities. But they no longer use it anymore because it's poisonous. Therefore, they now use what? Dinitrogen 1 oxide, alright, laughing gas instead. So please take note of that. Then the last one is this. I'll write it again, CHCl3 plus Cl2 again to create, that is UV lights. Now HCl is definitely formed. I've taken one, the last H, so I'm left with what? C. Now I've taken one Cl from the I to this, becomes what? Cl4. Now this is what? A tetrachloromethane. Alright? Tetrachloromethane is otherwise called what? Borax. Jam pass question. Please, a solution of borax in water is used to remove grease and coffee stains. A solution of borax in water is used to remove grease and coffee stains. It is very, very important. And this borax is non-combustible. It does not undergo combustion. Therefore, it is used as fire extinguisher. Please, they'll ask you, during the reaction between methane and hydrogen and chlorine gas in the presence of a UV light, which of the following are the byproducts, are the last byproducts? Please, you have to pick the last two byproducts. Or God, if you should allow your relationship to follow you, you are not picking these two or this and this. They will check you. You know, you as you are clicking it, you do like this. I've got to laugh over there. The jam of it, you'll laugh over there, they'll bring it down for you, they'll say idiots. So please, I'm telling you now, the last two products are what you are picking. The last two, that is the trichloromethane and the tetrachloromethane. So these are some of the reactions alkane undergo. Now, the next thing we are going to be treating, please, let me quickly say this. Methane is otherwise called marsh gas. Marsh gas. Methane is otherwise called what? Marsh gas. And it is found in dampy places, and it is highly volatile, and it is known as the principal constituent of cooking gas. They ask you, which of the following alkane series or alkane member is known as the principal constituent of cooking gas? Please, it is what? Methane. It is highly volatile. It is highly volatile. It can easily what? Catch fire. It is found in swampy or dampy places. Alright, so please take note of that. Now the next thing we are to treat right now is the distinguishing test of alkane and alkenes. Alright, the distinguishing test of alkanes and alkenes. Now, in what ways can we distinguish alkanes and alkenes? Distinguishing tests of alkanes and alkenes. Alright, now in what ways can we distinguish alkane from alkenes? Now the two compounds used are one, bromine water, and bromine water is HBr, is bromine water. Then secondly, you have potassium permanganate. Alright, it's also used to carry out the distribution test, that is KMNO4. Alright, this guy is actually reddish in color, and this guy is purple in color, and it's a good oxidizing agent. Alright, so let's do this. If these two compounds are reacted with alkanes and alkenes, listen very well. If these two compounds are reacted with alkanes and alkenes, if they decolorize, that is, if they change color, it indicates the presence of what? Alkenes. And of course, the alkenes are what? Unsaturated, due to the presence of what? Double bonds. They are what? Unsaturated. If they are reacted with bromine water and potassium permanganate, if they change color, if they change color or decolorize, it shows the presence of what? Alkenes, called what? Unsaturated hydrocarbon. But if they remain the same, that is, there is no change in their color, it shows the presence of what? Alkanes. And alkanes are what? Saturated. So please take note of that. It is very, very important. So these are the two compounds that can be used to distinguish alkanes and what? And alkanes. It is very, very important. So at this point we call it a day. Okay, no. Let me give you the members of the alkanes. Let me give you the alkane series. It is very important to know that. So please hope what I've said so far has been entering. It is very, very important to play the video over and over again to have a better knowledge of the topic. Now, alkane series. Now we have the methane. We have the methane. We have the ethane. We have the propane. We have the butane. We have the pentane. We have the hexane. We have the heptane. We have the octane. Heptane, we have the nonane. We have the king. We have undecane. We have duodecane. We have tridecane, tetradecane, pentadecane, hexadecane, heptadecane, octadecane, nonadecane, and the 20th member is the ecosane. Alright, so let me number it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So please, these are the alkane series. Everything about the alkanes has been treated. Just play the video over and over again so you can have a good knowledge of alkanes. So at this point, to call it a day. In our subsequent class, I shall be giving us I shall be treating alkenes and alkynes and how we can distinguish alkenes and alkynes. All right, we can use copper. We can use silver chloride. Okay, silver nitride to distinguish alkenes and alkynes. That is ammonia copper 1 chloride and silver nitrate. Those are the two compounds that are used to distinguish alkenes and alkynes. Silver nitrates and copper 1 chloride are the compounds used to distinguish alkenes and alkynes. But bromine water and potassium permanganate are the compounds used to distinguish alkanes and alkenes. Please don't take one for the other. It is very important. Thanks for watching and do have a wonderful day. Please endeavor to subscribe.